Good day, and today we're doing the paper 2 non-calculator from May-June 2025. Let's have some fun. Okay, so first we have the formulas page and then we jump into question 1. This is a simple collect the terms question. Find the terms that are similar. So we got a 7c plus, we always put a 1 in there, plus 1c. So 7c plus 1c will give us 8c. And remember, the sign always goes in front of the term it's worth. So this is the minus 5d plus 3d. Minus 5 plus 3, of course, is minus 2d. Okay, looking at the mark scheme. Basically what it says, you get 1 mark for 8c and 1 mark for minus 2d. Question 2, straightforward, find w, x and y. Right, so when we are doing these questions, read what it tells you. It tells us there are two parallel lines, so this has value. Okay, this means something. Right, having parallel lines, and the moment we see parallel lines, we need to look, of course, for that popular, okay, Z and N angles. Okay, don't ever call them Z and N in exam. They are alternate. Okay, looking for a Z, alternate angles, or two parallel lines, intersection, F angles, but of course we're going to call that corresponding. Okay. And of course it's co-interior as well. Okay. So having these two parallel lines, let's do just that. Okay. Let's use my pen. First thing I'm going to do is I'm going to look for a nice Z. Okay, so of course there's a Z there, which means this angle and that angle is alternate, they're equal. But I think the one we want to look for here is a nice stretched out Z. See that? That means this angle here is 158. Okay, of course this is just one of many ways of doing this question. There are other ways. Okay, and then we got the opposite angles. Okay, or even better, if you could send this corresponding, we have a big F here facing down, and there you go straight away, 158. Okay, looking for those alternate and corresponding angles. The first thing you do when you see parallel lines. Okay, what else though? Of course there's more Z's to look for here. Let's change color. Okay, here is a straightforward Z here. Voila. So that is clearly corresponding, X being 76. Okay, so now we just need to find Y. Now, again, there are going to be different ways to do this. Right? One way would be angles on a straight line here, which will be 180 minus 158. What does that give us? A 22, right? So this angle here is 22. And as you see before, we got another Z there. That means this one's 22. Or we can do angles on a straight line right over there. So all we got left to do here is angles in a triangle. 180 minus these two angles, which is 76 and 22. Okay, make sure you got your mental maths correct, since this is non-calculator, but that's easy. 180 minus 76 being 104. Do 104 minus 22. 4 minus 2 is, of course, 2. 10 minus 2 is 8. So y is 82. Don't make any silly mistakes with the calculations. Right, mark scheme 158.76.82. How much for each? Let's just see. So you get 1 mark here. Oh, why is it on red? 1 mark here, 1 mark for that. Okay. Alright, so you get 1 mark then for working out. Okay, so what I did here, this, if you have a 22 here, or there, you get a mark. Okay, and then doing 180 minus whatever you had, the x. Okay, so this mark or that mark, and then, so working out, see 4 marks, you know that working out is valuable. It's important to write the angles in here, because if they can't find the right answer here, you might get a mark here, so like that 22 if you have the answer there wrong. So always show your angles as much as possible. Moving on to question 3. Sally invests $1,500 at 3% per year, simple interest. Okay, this is a formula you need to study. Simple interest is, formula is I, which stands for interest, P, R, T, principal, rate, time, over 100. Learn that formula. Okay, study it. Okay, so P stands for principal. That is the money that Sally invests at the beginning. R is rate. Okay, so PR is the percentage. T is time. So to find the interest, this is the extra money the bank will give Sally. We need to do P, which is 1,500, rate, which is 3, and time, which is 6, divided by 100. Okay. Now, there are different ways to doing this. Okay. Remember, with times and divide, you can do things in any order. So we can divide this by 100 already. Basically, we can cancel this 100 with that. So we're left with 15 times 3 times 6. Okay. Again, different methods of doing this. We can multiply them in any order. I'm going to multiply the 15 and the 6 first, which is easy. That's 10 times 6 is 60. 5 times 6 is 30. Added together, that's 90. Okay, so that was a 56. So now what we have to do is do 90 times 3. And that's easy. 9 times 3 is 27. Add the 0. So the interest is $270. Okay, Americans still rules the world. We still do dollars. Okay, does it make sense? Well, yes. If she puts $1,500 in the bank at 3% per year, the bank will give her after 6 years $270. Okay. But that will not be the total value of her investment. She's not going to have $270 in the bank after 6 years when she put in $1,500. The bank would have stolen her money. Guys, remember, this formula only gives you the interest. Only the extra money the bank gives you, not the total amount you have in the bank. The total amount will be the money she put in plus the interest she has. The excess is the principal plus the interest. That gives you the total amount. So that will be $1,770. Okay, that's correct. Let's look at the marks. Okay, so basically, if you got 270, you get 2 marks, or you get 1 mark for having the using the formula correctly with the values substituted, and then you can get your second mark for that, and then your final answer. Or you can get a mark for, no, that's basically it, not complicated. All right, moving on to question 4, fractions. Okay, important, always remember bid mass. Okay, we need to do the multiplication before we subtract. So the 5, 6 and the minus, they can just hang around for a bit. We're going to do this first. Okay, there's two ways of doing this. You can do 2 over 3 times 3 over 8. Multiplication fraction is easy. Multiply the top with the top and the bottom with the bottom. Okay, and then of course to simplify things, you can simplify it. Okay, here we can divide both by 6, so that will leave us with 1 over 4. Or another thing you could do is you can simplify before you multiply. We can divide this 3 and that 3 by 3, that will make it a 1, and divide this 2 by 2 and that 8 by 2. Okay, and then we just go straight. 1 times 1 is 1, 1 times 4 is 4. Okay, that's the multiplication done. Okay, now subtraction a little bit harder. Okay, we need to have the denominators the same. So we need a common multiple of 6 and 4. The lowest one is 12. Or we could have used 24 there. We could have left it unsimplified. Which means we're multiplying this fraction by 2. That gives us 10 over 12. And we're multiplying this fraction by 3. That gives us 3 over 12. Equivalent fractions. Now we can do 10 minus 3 is 7 over 12. Final answer. Let's have a look. Alright, 7 over 12 or equivalent. Okay, so this means that we don't have to have it in its simplest form. Okay, so you can have 14 over 24, still get full marks. Okay, or 28 over 48. Okay. So you get 1 mark for 6 over 24 or equivalent. So 1 mark for this multiplication I did, or that one of those, yeah, not both. Then you get a mark for a common denominator. So this is, I got the 12 here, can be a 24 as well. Okay, and then of course a mark for the correct answer. Doesn't have to be simplified. Special case, for some reason you got 1 over 16. I'm going to delve into that one. And you don't get any other marks, you get 1 mark for that. Okay, I guess that's when you subtract. You don't follow bit mass, but you do it correctly. Okay, going on to question 5. The interior angle of a regular polygon is 150. Find the number of sides of this polygon. Again, there's 2 ways to do that. Okay, so some people will know this from memory, but remember you've got now a polygon. Polygon's got many sides. I don't know how many sides this has, but I'm going to draw just 2 sides. Interior angle is 150. Okay, remember, if interior angle is 150, the exterior angle will be 30, because interior plus exterior is always 180. And we know that exterior angles of any polygon always equals 360. So all we need to do here is divide it by 30 to get the number of sides. Okay, cancel the zeros. 36 divided by 3 is 12. Is that correct? Yep. Now there is another way of doing this, and that is using the formula for the interior angles of a polygon. But that takes a bit longer, it's a bit more complicated. Okay, so using the exterior angles, I find that a lot easier. Okay, so here again you get a mark for basically doing the working out, getting the exterior angle, dividing it into 360, and then for the answer. Right, moving on to question 6. So I'm moving to a different board here so I can draw straight lines. Okay, it shows us the line x plus y is 7. And then it tells us to draw y equals 2x plus 1. Again, there are different ways of drawing a straight line y equals 2x plus 1. Okay, y equals 2x plus 1. One is using, of course, the general formula for any straight line, y equals mx plus c. C being there at the end, that's the y-intercept. Okay, which means we know that that line, okay, always use a pencil for this. Alright, my pencil is green. On there, use a pencil that is going to go through 1. Then we can do the 2, which is the gradient. Okay, remember gradient is always the change in y over the change in x. So we can say this will be 2 over 1. Means for every 1 square we go on the x-axis, we need to go 2 squares up. So we go pencil 1 square to the side, 2 squares up. 1 square to the side, 2 squares up. That will be the line. Okay. Another way, of course, is you can just draw yourself a quick table. Pick some values. Okay, make x 0. So x is 0. 2 times 0 is 0. Y is 1. Then you make x 1. 2 times 1 is 2 plus 1 is 3. So that will be 1, 3. That will be the point there. And then you make x 2. 2 times 2 is 4 plus 1 is 5. And then you got 3 points. See, 2, 5. You can plot. Many ways to do this. Either way, you take your ruler. Once you have at least, well, you need 2 points to draw a line, but if you got 3, it's better. Okay, that's the line. Let's see if I can draw. Oh, no. There we go. Now we draw the line. Bam. Done it. Okay. So, easy as that. 2 marks. Quick and easy. Quick and fast. 2 marks. Right, there's a use the graph to solve the simultaneous equations. Okay, and that's also so do is 1 mark. So you know I shouldn't be spending a lot of time on this. It should be straightforward because you only have to read up where they cross. Okay, and where they cross, the coordinate is along the corridor 2 up the stairs 5. Remember, the first value is the x, the second one the y, so that means it's 2, 5. Okay, makes sense because 2 plus 5 is 7. And here if y is 5 and we make x 2, 2 times 2 plus 1 is 5. Bam, that's also correct. We know it's correct. It's only 1 mark, you know, it should be easy, should be quick. Okay, or they would have given it more marks. And that's it. Question 6 done. Question 7. Right, 0.26 recurring as a fraction. Give your answer in the simplest form. This is when you have to do that little bit of algebra. Okay, first we say, well, x, we make 0.26 recurring. Remember, it means 0.2666. That's what the little dot is. Right. So now there's different ways of doing this. People do it different ways, but I just think there's one number recurring, so I'm going to times my equation by 10 on both sides. Okay, so that means 10x will be 2.6666. Okay, then I'm just going to take this first equation and write it down here again. You'll see in a moment why. So x equals, and make sure everything is perfectly lined up. Okay, meaning the equation, the x's, the decimal points, and each value. Okay, because that will show clearly then why the next step will work when we subtract the bottom equation from the top equation. 10x minus 1x will give us 9x. And then 6 minus 6 is 0 up to infinity. That means we're getting rid of the infinite amount of 6's. So all we need to do is 6 minus 2 is 4. Carry the decimal, 0.2 minus 0 is 2.4. Okay, now let's say this is my favorite way of doing it. This is, some people multiply it by 100, which can also work. Okay, either way, so we want to know what x is. We just divide both sides by 9 and divide the 9 there, so it's 2.4 over 9. Bam! That is this fraction, isn't it? Not quite, because in its simplest form, a fraction doesn't have any decimal points. We don't mix decimal points and fractions, because if we do, there's actually an infinite amount of fractions we can write. But we can fix that by simply doing equivalent fractions. Remember, equivalent fractions is we multiply the top and bottom by the same number, so that will give us 24 over 90. Bam, got it. Fraction. Is it in its simplest form? No, it isn't. Okay, but let's not complicate it. You could just we probably divide both by 4, but I don't know. Let's just half both. Let's half both. That will give us 12 over 45. Can we half it again? No. Can we divide it by 3? Yes, we can divide both by 3. So we could have divided by 6 straight away, but anyway, this still works. So we get 4 over 15. Can we divide them by... No, that's it. 4 over 15. The other method, of course, is you do the first step, you multiply both sides by 100. And then you can skip this step. I mean, there is other ways of doing this. Okay. So, you see, they did the divide times it by 100. There. Okay. So you do it that way, that's fine. Then there's other ways to do this as well. But basically, you get 2 marks for this, 2 marks for this or for that, either one, and for simplifying it. Okay. Question 8. Vectors. Okay. It describes movement. Alright. So 2m just means we got the vector of m, we got it twice. So 2m will be 2, 11 over 5, which actually is 22. No, do not put a line there. This is not a fraction. 22 over 10. Okay, that is the first vector. Then we need to subtract n, which is 8 over minus 3. So straightforward. 22 minus 8, of course, is 14. And then 10 minus minus, 2 minuses make a plus. So 10 plus 3 is 13. 10, 13. Okay. So, marks here. If you got everything wrong, you can get 1 mark here. Or, if you have got 1 mark for that, 1 mark for that. Not 3 marks, yeah? That's how it works, okay? Right, magnitude of a vector. It basically tells you how long is the vector. So imagine we got a vector here, which means we got something moving from there to there. The top number tells you how much you moved left or right. Okay, so that basically tells us we've moved 5 to the right. That's the top number there. And then to get there, the bottom number tells you how much up or down. Assume this must be positive because it's square root. Can't square root a negative, right? So moving up, this is square root y. Okay, that's what the magnitude is. The magnitude is how long is this line? That's the magnitude. Okay, and they told us, well, it's 7. Alright, so as you can see, here we got a simple Pythagoras problem. Okay. And in this case, Pythagoras would be 7 squared equals 5 squared plus square root y squared. Pythagoras. The hypotenuse squared equals the other two squared combined. Okay, so we can work this out. 7 squared is 49. 5 squared is 25. And what happens if you square the square root? Yeah. Let's say we got the square root of 9 squared. Square root of 9, of course, is 3. 3 squared is 9. There's the opposites. They just cancel each other out. So the square root of y squared is just y. Bam. You see how close we are? Just subtract 25 from both sides, which of course will be, what is that? 24. Y is 24. That cannot be. Can it? It's impossible. That's the hypotenuse. Well, yes, it can. It can. Because this length isn't 24. Y is 24. So it means this length is the square root of 24. Okay, which if the square root of 25 is 5, this will be 4 point something. So yes, it can be. The length of the line can't be 24, but it can be the square root of 24. Okay, which you can imagine, 4.9. I'm just making this up. Okay, you don't have a calculator, but this is how the logic works. 24 is correct. And showing Pythagoras, that gets you a mark. Okay, so showing Pythagoras, 1 mark. Yeah. And then for the final answer, 1 mark. Okay. Oh, one of these questions, they ask it backwards. Okay. Students scored a mark scored a student in a test. So, this, I guess this is out of 10. So 2 students got 4 out of 10. These are the ones that didn't study. You're studying now, which is good, so you won't get that. 4 students got 5 out of 10. They studied a little bit, but you're studying hard, so you're not one of that 4. You're one of these number of students. You know what I mean? They got 8 out of 10. Okay. And it tells us the mean mark is 6. I have no idea how to do this. So what I'm going to do is I will do what we normally do. We need to add up all the marks of all the students. So these 2 students, they both got 4 out of 10. So we will do 2 times 4. They got a total of 8 marks between them. These 4 students, they got 5 out of 10. So they got a total of 20 marks between them. So these n number of students, they got 8, so they'll have a total of 8n. Okay, those are now we need to add this all up. We do 8 plus 20 plus 8n. That means we got a total of 28 plus 8n marks. And then to work out the mean, of course, you add up all the marks and you divide it by how many students there are. So how many students are there? Well, it's 2 plus 4 plus n students. So that will be 6 plus n. Not 6n, 6 plus n students. Okay. Right. So that's the calculation to get the mean. If we knew what n was, we can just put it in there and we'll know the answer. Oh, we have the answer. The answer is 6. On average, the students got 6 out of 10. So now we just need to solve this equation here. Okay, this one here. I mean, this is just that simplified. All right, so let's get rid of the fraction. I'm going to multiply the 6n over there. So we get 28 plus 8n is 6 times all of that. So that means 28 plus 8 plus 8n. Expand the brackets, will give us 36 plus 6n. Now just rearrange it. I'm going to leave the 8n on the left and subtract the 6n. Leave the 36 on the right and subtract the 28. Well, basically I'm subtracting 6n from both sides and 28 from both sides. That gives us 2n. 36 minus 28. What is that? That is 8, isn't it? And then we divide the 2. So that means there were 4 students. We got 6 out. Does that make sense? We can do a quick check. So if this means there's 4, it means in total there are 10 students. And then 8 times 4, this will be 32. So we do 8 plus 32, that's 40 plus 2, that's 60. 6, the mean is 6. Yes, so I know it's correct. Even without checking the mark scheme. But there it is, there's the mark. 4 is the answer. Okay, if you remember I wrote 4 on the line. Okay, not from wrong working. So you can't guess this. You can't just write 3 on the line, you guess, trial and error. You can't do that. It has to be working out. So you need to have these previous marks before you get the final correct answer. Okay, so basically they say you get a mark for writing the first equation here. That's not my red pen. That's a mark for writing an equation, for solving it. And then you get this mark if you got the other marks. Right, on to question 10, and this is circle theorems. Right, my best advice here is before you even look at the questions, just try to find as many angles as possible. Okay, one thing to always look out for is the radii or radiuses of a circle. They are always the same length, and they always forms a nice isosceles triangle. And the thing about isosceles triangle is the base angles are the same, which means if this is 35, this angle over here is 35. Okay. And in exam, you're allowed to highlight the stuff, anything in the question. So it's a good idea to do that. All right. Another theorem we can look for is the one of the angle between a radius and a tangent. Okay, the angle between a radius. I'll go here to GeoGebra to show you these theorems, which you need to study, of course. And it's this one I'm talking about. Okay, the angle between the radius and the tangent is always 90 degrees. So meaning this angle here is 90 degrees. We already have 35, of course on the other side is also 90. We already have 35, so if we do 90 minus 35, that means the angle over there, CAD, of course, will be 55. I'm not good at doing my 5s. Yeah, so we got that 55. Okay, and remember this is 90 here, just in case. Okay. What else do we have? Okay, then I'm thinking of whenever you see a triangle inside a circle, right? With the angles of the triangle on the circumference, you need to, and the tangent, you look for the alternate segment theorem. This one over here. Okay, so you see we got a triangle inside, we got the tangent. Now look carefully here. 57 over here, 57 over there, 65 over here, 65 over there. Doesn't matter how I move this, right? The angles might change, but it stays equal there, okay? Look, if I change this one, which is 60, okay? The two green angles change, but this stays 60, that stays 60. That's the angle, right? If we move this one, 55, 55, look, now the other one will change. 55, these two stays 55. Those change, but they stay the same. So that's the alternate segment theorem. So which that tells us is that this angle here, DAC 55, equals this one over here, which is 55. If only I was better at making 5s. I don't know why. I find it so hard. Okay, what else is there? Well, the angle at the center, this is called the arrow theorem. It doesn't always form an arrow, but the angle at the center is twice the angle on the circumference. Theorem number 1 here. Okay, so can we make this smaller? No. But you see what I mean? Look, the angle here in the middle is 110. The angle in the circumference 55. Granted, that they come from the same 2 points. Okay, to change these points, the angles change, but this one at the center is always double the one on the circumference. You see that? Better, even though if I move this one, see, it stays 60, even though it's 120. Sometimes it doesn't form an arrow. Yeah, it can be like this, or even like this. All right, but often it comes forward as an arrow. Okay, angle at the center is twice the angle on the circumference. That's what that one is called. So it means if we got 55 here, this one over here is 110. But of course, we could have gotten that just by doing a 180 minus 35 twice. All right, we got a good fair amount of angles here. I think we can move on to answer the question. Okay, so we're going to let the question cloud our judgment. All right, angle AOC, there we got, see, 110. Now we can just put it in. Angle ABC, there we go, that's 55. Angle DAC, again 55. See how good this is going now. Isn't this fun? Angle OAB, oh, this one we don't have. Okay, but I don't think it's a big problem, because simply, look, we got a triangle like this. In this triangle, there's those two form one angle, that forms an angle. So all those three angles together should form 180 angles in a triangle. So from that, I'm going to subtract this angle here, which is 55. This angle here, which is these two together, which is 35 and 40. And that will give us this angle, of course, but then we already have that part, and we want that part. So we can chuck in the 35 as well. Okay. So, what's the best way to do this? Well, these two together is 70. So 180 minus 70 is 110. And then I still need to subtract the 50 and the 40. I'm going to subtract the 40, because 11 minus 4 is, of course, 70. Minus 55. And that will give me 15 for angle OAB. And that's it. All that's left, if you have the mark scheme. 110, 55, 55, 15. 110, 55, 55, 15. 1 mark each. Okay, now I'm sure there is some follow-through marks. Okay, so meaning, and you can always do this. So let's say you don't know what this one is, and you guess it as 120, which of course is wrong. But then you guess this one's 60, then, and you write 60 here, you get a follow-through mark. So if you do recognize the circle theorem, but you don't know what the angle is, you can just guess it, write it down in the sketch, and then you can get a follow-through mark for that one. Okay, this is what these follow-through marks is, which means if you got the first one wrong, for example, but then you do the right divide, that answer by 2, you get a mark here. Okay, and then if you copy the same wrong answer here, you can get that mark if it's less than 90. Okay, so if I had this 120, 0 marks, but I have the 60 and 60, I get those 2 marks. And then again, follow through 70 minus their b. So if you had this 10 then, because I had that 60, so it's 10, then you can get 3 out of 4, even though you have all of them wrong. Okay, so follow through from marks is a real thing. If you need an angle to find another angle you don't have, guess it. You can always get a mark. So question 11, shift to another board. That means now I can draw a tangent. Okay, so they say the tangent from P to the function. So tangent, of course, goes through P and it touches the line. Okay, so take my ruler, I'm going to draw a tangent. I think it's going to look like this. Beautiful, beautiful. Okay, so be accurate. It touches there. Where does it touch? Can we say with confidence it's right there on 1? So this will be the point 1 on the along the corridor, up the stairs. So let's see, from there to there, there's 1, 2, 3, 4, 5, 6, 7, 8, 10 squares. So every 2 squares counts for 1. So let's see, it's 1, 2. It's very important to get the S. So every square on the y-axis is half a value. Okay, so that will be 2. 1, 2. 1, 2. Okay, find the equation of the tangent, give your answer. So, y equals mx plus c. First, easiest one to find there is the c, which is the y-intercept. And that is where, that it is, that's the c, that's where it crosses the y-axis. So we know our equation is going to y equals something, x plus 5. Okay, then we just need to find the gradient, and there are different ways of doing this. Okay, different ways of doing this. Let's change color. Gonna do a good yellow. Okay, one thing of gradient, remember it's the change in y over the change in x. Okay, so I mean, if we draw a triangle here, which makes this 1. So the change in x is 1. And it's always nice to make it 1, because then change in y, which I think goes from 2 to 5, is 3. That will give us 3. Okay. Now I think it's right, but there's other ways to do this. We could, okay, you don't have to do everything I'm going to do now, just you could, if you want to check your answer. You can check this equation, y equals mx plus c. Remember we said the c is 5, that was easy to find. And then take any point on the line. Let's take the point they've given us, because that's the most surest thing. Okay, because there we got an x and a y. So we change the y for 11. And we change the x for minus 2. And then we solve this. So move the 5 over there, 11 minus 5, and multiply this together. So m times minus 2 is minus 2m. 11 minus 5 is 6. And then we divide the minus 2. 6 divided by 2 is minus 3. Which is correct. We forgot the minus. Because remember, a graph going up from left to right is positive, and going down is negative. So it's good I checked that, because now I know I forgot the minus. You need to put the minus in. Don't forget the minus. Okay, let's see how the marks is awarded here, because I think this is quite important. All right, there we go. First one, 1 and 2. So they don't give a scope there. Okay, so yes, first question there, you get a mark for the correct tangent and a mark for that. If you don't have the tangent, you get 1 mark each here. So 1, 2, you have to be exact. Tangent has to be very accurate. Okay, they got no leniency there. Okay, and then second one, 5 minus 3x. Oh, you can have it the other way around. Of course, I got minus 3x plus 5. That's fine. Okay, again, follow through mark here if you got that one wrong. Okay, to just sum up quickly what they said there. Whatever your tangent looks like, if you have where your line, your tangent crosses the y-axis, you have it there, it's correct. So for ours is plus 5. If your tangent was wrong, let's say you went through 4, you have plus 4, you get a follow through mark. 1 mark for showing the rise over the run. or any method to find the gradient. This either you can use two coordinates, remember, you can use the formula for the gradient, and then for having minus 3x. If I've left that minus out, I would have lost 1 mark. Don't forget the minus. Okay, and that's that for question 11. We're on to question 12. 120 adults spending time on the internet. It must be the Gen Z or no, anyway. Is recorded for 1 day. Right, the cumulative frequency shows this information. Remember, this is when all the times are being added up as we go along. Right, so altogether there's 120 adults spend 10 hours on the internet. Altogether. Okay, so we need to find the interquartile range. Okay, so to do that, we need to find first the median. Alright, use your ruler. So the median is the middle guy here, which will be around about the 60th person. He will spend, we have to be accurate here, then go down, use a ruler, right about there. Okay, so let's see how much each square is. Between 0 and 2, there's 1, 2, 3, 4, 5, 6, 7, 8, 10 squares. So each little square needs to count 0.2. Let's see, 2, 4, 6, 8. Yeah, that will be 1, 12, 14, 16. Yes, sir. 0.2. So this will be 5 hours. So this will be 4.8 hours. So the median we'll say is 4.8 hours. Okay, so 50% of people spend less than 4.8 hours on the internet and 50% spend more. Well, that's a lot. Okay, now we need to find the quartiles, the quarters. All right, let's use a different color here. So the lower quartile will be half of the bottom half. If you half a half, you get a quarter. Yeah, cut the pizza in half, you have half a pizza. You cut that half in half, you have a quarter of pizza. Okay, which is not enough pizza for me, but anyway. So half of 60 is 30. This will be the lower quartile. So you take your ruler, you go across till you meet the graph, you go down. Okay, remember we see where this point 2. So the lower quartile will be 4.2 hours. Okay, that's the lower quartile. And we do the same here. We cut the upper half into half. So there's 3/4. Yeah, so you took your pizza, you cut it in half, you put that half aside. Take the other side, you cut it in half. So now you've got a quarter. You put that quarter with your half, then you got 3/4 of pizza, which is not a whole pizza, but it's more than 1/4. Alright, so this will be the upper quartile, which will be at 90. You see, halfway between 1 to 30. Again, you take your ruler, you go across till you meet the graph, and then very accurately you go down, 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 down. Okay, and that will be the upper quartile, and we looked at 5.2, 5.6, 5.6 hours. Okay, so the interquartile range, interquartile, we call it the IQR. Interquartile range, no, interquartile range, okay, is always the upper quartile minus the lower quartile. So in our case, it's 5.6 minus 4.2, and that will be 1.4 hours. So basically, it's the distance between this. The middle 50% spend, well, the difference of the time they spent. Okay, 1.4 hours. 1 hour 40 minutes, 1.4 hours. Yep, that's exactly, can't have anything else. 5.6 and 4.2. So You get a mark either for 4.2 or 5.6, either one of these, and 1.3. If you got 0 marks, but you got 0.7, special case, you can get 1 mark. Okay. Now, 70% spent less than K hours on the internet. Use the schema-free diagram to find an estimate of the value of K. So, 70%. 70% of 120 adults. Remember, so there's 120. Remember, this was, lower quartile was 25%, the median was 50%, as upper quartile says. So we have to estimate, it should be around about here. Yeah, within lower quartile. But how do we get exactly 70% of 120? Well, we know 70% as a decimal and multiply 0.7, and we multiply that by 120. That's how you find 70% of something. Okay, this is not hard to do, because we know 7 times 12 is 7 times 84. So 7 times 120 would be 840, but there's one decimal there, so 8.4, so yeah, it's 84. Okay. Which makes sense, that 70% of 184, it can't be 840, it can't be 8.4. So logic applies here. So, the 84th individual person is in the 70th percentile. So let's see. Here it also goes up in twos, yeah? 2, 4, 6, 8, 10. That's 10, 12, 14, 16. Yeah, so it goes up in 2. So the 80, what was it? The 84th person would be 2 squares above 80. That will be the 70%. Let's go this side, 70%. Percentile. So again, we just go across with our ruler till we meet the graph. And then we go down. And there we go. 5.4. 5.4 was the question. Use config to find an estimate of the value less than 5.4 hours. Okay, 5.4. Okay, is the hours or days. You don't have to write hours. Let's see. 5.4, yeah, it has to be exact. Only that. 1 mark for 84 seen. So, if you got 84 anywhere, or I guess if you started your line here at 84, 1 mark, and then 1 mark for 5.4. Moving on to question 13. Alright, always read the information very carefully. Diagram A shows solid A, solid B. Got that, solid. The same as solids. There's solids, so they filled up with something. Solid A is made from a hemisphere. There we can see half a sphere, and a cone. There we can see that. Each with radius 6 centimeters. Yes, okay. See, there is there, but they focus our attention on that again, which means all of these is important. The cone is sloping edge of 10 centimeters, right? Every little detail is important. Even though you can see it, they tell you it again. They tell you it again, even though you can see it, it means you're going to have to use each one of these words has a meaning. Solid B is a cylinder, yeah, I can see that, with a radius of 4, yeah, I can see that, and a height of h. That's silly, people, don't give me the height. The total, in bold, surface area of solid A equal the total, again in bold, so it must be important, of B. Okay, work out the value of h. Great, 5 marks. So, you know what I would do? I would start by what they've given me, and they've given me more than just this. Okay, let's do this like this, okay? So there's solid A and solid B, and they're equal. That's good. Now in solid A we have a hemisphere, and we're talking here about surface area. So we go to page 2 of a paper where we got a list of formulas, and we look for a hemisphere. We're looking for surface area. So there's the surface areas. There's 1, 2, 3 of them. Okay, curved surface area of a cylinder. You might need the later. Curved surface area of a cone. Great. and surface area of a sphere. There's no hemisphere, but what is a hemisphere? It is half a sphere. So we're going to start with this. 4 pi r squared. 4 pi r squared. That is the surface area of a sphere. So a hemisphere would be just half of that. Okay. So we cut it in half. We got half. It's easy as that. Okay. And remember, the disc there, the circle disc there, that is inside the shape. So that does not form part of the surface area. So that doesn't matter. So we just need to take the formula of a sphere and divide it by 2, which by the way will be 4 divided by 2 pi r squared. We can do that. Okay, so that will be for the hemisphere. Okay, but then there's the cone. We go back here and we saw that curved surface area of a cone. Again, we have the cone here. The cone has a base, but that base is inside the solid, so it doesn't form part of the surface area. So we can just use this formula. It's pi r l. Please note that L is the sloping edge. Okay, which, there they say it. See, every word is important. Sloping edge is 10 centimeters. Okay, so the total surface area of solid A will be these formulas. Okay, that will equal the total surface area of the cylinder. So go back here, and here we see this cylinder. Curved, there's the word curved as well. So this does mean something. 2 pi r. So what does that mean? The curved part of this cylinder, let's highlight this in color, is this part. No, not that part. Can I not? That's it. This is the curved part, okay? This is the curved part of the cylinder. The curved part, like a pipe, yeah? And what was that? That was 2 pi r h. Good. We got pi. We got r, a radius. And h is 2 pi r h. 2 pi r h. 2 pi r h. Okay. But that is only the curved part. And this cylinder, they do have, because on the outside, not in the inside like on the left. Like on the left, yeah. Not here like on the inside. That is on the inside. So it's not the surface area. But with the cylinder, this is on the outside. So yeah, this is this. Oh, that's ugly. There and there, 2 of them, 2 circles, 2 discs, 2, yes, and each one of them is the area of a circle, which by the way we have over here, pi r squared. Okay, so that's pi r squared and that's pi r squared. So 2 discs, one at the top, one at the bottom. So we need to add twice the area of the 2 circles. Bam! I'm sure already I've got a lot of marks there just by writing down the correct formulas. Now we can put numbers inside. Right, that would be the next step. So here we got 2 pi, and then the radius for shape A, hemisphere, is 6. 6 squared. And then we got pi. The radius again is 6, and the slant or the sloping edge or the slant edge, the slope, that's 10. Over here we got, not an ugly 2 pi, and now the radius of the cylinder was 4. The height was it 10? No, the height is h. We don't know what the h is. Don't guess, man. The height is h. That's what we want to know. 2 pi and the radius is 4 again, squared. Okay, you see we've used all of this. We used the fact that they are solids. Okay, to determine which is on the surface area. Okay, we used the hemisphere. We used to find hemisphere by dividing the formula sphere by 2. Okay, we use the word cone to find the right formula for the cone. Okay, we use the radius, which is 6. We use the sloping edge of the cone. You see, every word there has meaning, and we have to put that meaning in our formulas. The cylinder, okay, and then the radius is 4, and we saw that the cylinder was, yeah, so see, every word has an importance when we do this. All we need to do now is we need to simplify this as much as possible. Simplifying is simple, because you do 6 squared is 36 times 2 will give us 72 pi. 6 times 10, that will be 60 pi. Here we can do the 2 times the 4, that will give us 8 pi, and the h. And then 4 squared, 4 to 16 times 2 is 32 pi. Okay. Now the pi is just a number. So we can take pi as like how we use an x. If we got 72x plus 60x, we can add that together. What would that be? 132 pi. What would it be? 113 pi. Okay. It will be 132 pi. Then I can move this 32 pi there. Remember, I cannot add these two together because there's an h, and this one doesn't have an h. You can't add an xy and an x together, or ab and an a. You can't add them, right? They're not similar terms. But we can move this 32 over here. So we leave the x by h there because I can't add them to the other one. Just leave it there. Oh, that gives us a beautiful 100 pi. Okay. Okay. Now we want to know what h is, so we need to get rid of the 8 pi, and this is 8 pi times h, so we move that to the other side. We're going to divide it. And now, of course, this is a non-calculated paper, and you say, what am I going to do with the pi? Well, you're just going to cancel it. Pi, cancel pi. So our answer, h, is 100 over 8. Did they tell? I guess we can just write 100 over 8. But if you're not sure, do I simplify it? Do I not? Students always ask. If you don't know, just do it, man. Let's simplify it. If you will, you know what 100 divided by 8 is brilliant, because you just half it, half it, half it again. Yeah? If you divide something by 2, you get half of it. You divide it by 2 again, you same as dividing it by 4. Divided by 2 again is by dividing by 8. But, sorry, it's 12 and a half, if you know. But if you don't know, you can always go, well, that's 50 over 4, which is the same. I'm just simplifying this fraction. And so that is 25 over 2. Half of 25 over 2, 12.5. Let's see what the mark scheme says. 12.5 or equivalent. Or equivalent. So yeah, you can write 100 over 8, 50 over 4, 25 over 2. They're all equivalent. So they're not too fussy about simplifying it. Okay, marks. In short, probably 5 marks. I guess you will get. I'll make this easy. Well, one more, not for writing down the formulas, but using the formulas, putting the right. So this line here will be 1 mark. And this line here with the correct number, it will be 1 mark. Okay. And then, and then putting them equal to each other is another mark. So yeah, that line is 3 marks. Big one there. Then simplifying about up to here is another mark. And then any of these answers here, 1 mark. And that's 5 marks. Okay. Not too difficult if you break it down into little parts and use every word up there. Work out the height. Well, that's not difficult, is it? Work out the height. Oh, solid A. I was just like, what? We got the height. 12.5. The height of solid A. Man. Right. So the height of solid A. So we need to find this. Which, look, that is 10. Oh, beautiful. A right angle triangle. And then have this as well. What could that possibly be? Swing it down. The radius of a sphere always stay the same. So this is 6. And we just need to find this. Let's call it x. And of course, here we have Pythagoras. Okay. The hypotenuse is the slant side, so the hypotenuse squared equals x squared plus 6 squared. Okay, so let's do that first. Okay, I'm going to say 10 squared equals x squared plus 6 squared. That means 100 equals x squared plus 36. So 100 minus 36 is 64. Then we just need to square root it, and we got x is 8. Well, plus minus 8, but we can't have a negative length, so this 8 is good enough this time. And then all we need to do is add that bit, which is the radius, which stays the same. So 8 plus 6, 14 centimeters. Yep, Pythagoras. Well, just get 2 marks for Pythagoras. 1 mark for writing the rule, and then 1 mark for somewhere square rooting at some point. And then for the answer. Brilliant. You're doing well. You're doing well. Okay, functions. Question 14. Functions. Alright, they always start off with an easy one. Function of x is 3x minus 2. Can you just see they've changed the x for a minus 2. So you change that x for a minus 2. So the function of minus 2 is 3 times minus 2 minus 4. 3 times minus 2 is minus 6 minus 4 minus 10. 1 mark. Okay. Nothing else. You got minus 10 on the line, you get the mark. You don't, you don't. Right, inverse of f1. That means we need to do this backwards. Okay, that means if we start with x, right, what's the first thing that happened to x? It was multiplied by 3. That's how you get 3x. And then they subtract 4, so that's how you get 3x minus 4. So now we just do the opposite. We could do x instead of minus 4, we plus 4. That will give us x plus 4, and then times by 3, we divide by 3. That will give us x plus 4 divided by 3. That's it. X plus 4 divided by 3. If that confuses you, there's another way of doing this. It's the same as changing the subject. Okay. So if we have to make x the subject here, we'll do first move the minus 4 to the other side. It will become plus 4, and then divide the 3, so y plus 4 divided by 3 is x. If you do it this way, that's fine. Just remember to change the y for an x in your answer, because if you look at the mark scheme, okay, x plus 4 over 3, or equivalent, I guess that means just what could be equivalent to that, x plus 4 divided by 3, that's equivalent. Okay, well anyway, yeah, just not too complicated. Correct first step, which means having x plus 4 as 1 mark, and then for the final case, make sure to swap the y for an x if you use the second method there. Okay, next one. The function of f, the function of g equals x. Okay, now there's again different ways to explain this, but let's first write down the function of f. The function of f is 3x minus 4. I'll leave some space in between them, because then in the function of f we need to put the function of g. So then we put the function of g, which means inside there, instead of the x, we put g, which is 4x plus 1. So inside the function of f, we put the function of g. The function of f is 3x minus 4. With the x's, we put the function of g. All right. Then we expand the brackets. 3 times 4x is 12x. 3 times 1 is 3. And at the back, there's hanging around the minus 4. So that gives us 12x. 3 minus 4 is minus 1. So you can see what's in front of the x, that is a, and what comes at the back, that is b. So a being 12, b being minus 1. 12 minus b. Okay, Right. So this is 2 marks. 1 mark each, but if you get this wrong, screw it up, you get 0, you get 1 mark for doing this. Okay, so show you're working out, you never know. Right. Question D. Well, it looks like a function question, but in reality, this is only a simplifying algebraic fraction question. So, we got the 2, and below it, we got the function of x, which was 3x minus 4. We got a minus. This is a big minus. Don't forget about this minus. It's going to make things complicated. And then at the bottom with the function of g, which is 4x plus 1. Okay. Now here we're going to do the smiley face method. What is the smiley face? Okay, if we had, for example, 2 over 3 minus 1 over 4. Yeah. Remember, to do this, we need to get this common denominator, and we can do that by multiplying the 2 bottom ones together. That will give us 12. And then multiplying the 2 with a 4, that will give us 8, because 8 over 12 is the same as 2 over 3. Put the minus in the middle, and multiply it. Okay, so this is a shortcut. Getting the denominator same and having equivalent fractions, and that gives us 5 over 12. That's how you can do this question. You see it forms like a smiley face. Some people say it's a butterfly, if you draw circles around it, whatever. So we're going to do the same. We're going to follow this pattern over here. Okay, we're going to put the equal. First we're going to multiply these together, but we don't have to go through all the jazz of multiplying out double brackets. We can just write them next to each other. Okay, and you don't have to. You can if you want, but why do something if you don't have to do it? Then we're going to multiply this there, which means it's 2 times 4x plus 1. Then the minus. Oh, this is gonna. I explain to you how this is where. This minus is where everybody always goes wrong. Okay, put the minus. Then there's a 5. And then there's the 3x minus 4. Keep your eye on this minus, okay? Keep your eye on it. Don't let it out of your sights. Okay, now when they say simplify single fraction, we need to say we can leave the bottom the same. Okay, I don't know why this has happened. Okay. And then we expand the brackets. 2 times 4x is 8x. 2 times 1 is 2. Minus 5 times 3x is minus 15x. And 5 times 4 is 20. And a minus is a plus. Okay. Again, this is where the trouble lies. The minus makes a plus. And they said minus 5 is okay. Get those signs right, because if you're going to make mistakes, lose marks, that's where you're going to lose it. Okay, now we've got the final answer now. Yes, we do. We leave the bottom the same. Eight x minus 15x is minus 7x. And 2 plus 20 is plus 22. Or 22 minus 7x, they like to swap around the answer. So, yeah, see, you can expand the brackets, but if you make a mistake, then you can lose a mark. Okay, so minus 7x plus 22, that's what I have. They just have it in different order. I left, oh, no, don't do that. Look, see, I left out that 1. That can cost you a mark, so be very careful. Okay, right, final answer. Okay, so easy. You get 1 mark for this. 1 mark for this, and then 1 mark for the final correct answer. Okay, make sure to get the signs correct. Question 15. Expand. Okay, let's go. Right. So there's different things with it, but yeah, you have to multiply the first one with the first one. 2 times 1 is 2. First one with the last one. 2 times minus 3 is minus 6, and that square root 5 hangs around, like kind of like an x or an a or whatever. Okay. Then minus 5 times 1 is minus 1 square root 5. Now, that 1 is not necessary, but I'm just putting there so you know, it is there. If you put it, it's not wrong. But you can leave it out. And here's the big one. Here's the big one, right? We got minus square root 5 times minus 3 square root 5. Okay, let's just think. A minus and a minus, this is going to be positive. Okay, imagine there's a 1, like we have a 1 over there. Minus 1 times minus 3 is plus 3. Okay, and then square root 5 times square root 5 is, I'm going to put this in brackets, 5. Okay, because square root 5 times square root 5 is the same as square root 5 times 5. You know your laser search, which is the square root of 25, which is 5. So if you multiply a root by itself, it cancels the roots. And of course, then 3 times 5 is 15. So we have a plus 15 at the end here. Okay. Now, remember what I said? That square root 5, you can imagine it like an x. If I had minus 6x minus 1x, I'll have minus 5x. Okay. So minus 6, no, you won't. That's a silly mistake. Because minus 6 minus 1 is minus 7. So we'll have a minus 7 square root 5, not x. And then, of course, we have a 2 plus 15. Okay, which is 17. And that is hopefully the correct answer. 17 my final answer. Okay. Alright, so only 2 marks to be given here. So for this first line, working out 1 mark, final answer 2 marks. Continuing with search, question B, rationalize the denominator. Okay, remember you can multiply any fraction by the same number, top and bottom, and it will be an equivalent fraction. So here we're going to multiply it by square root 10. Square root 10 over square root 10 is 1, so we multiply over the same. So the top will have 6 square root 10, and the bottom, remember, you multiply a root by a root. 10 times 10 is 100, the square root of 100 is 10, the roots cancel. Okay. The simplest form, so if you can imagine, 6 over 10 is the same as 3 over 5. We divide the top and the bottom by 2. That gives us 3 square root 10 over 5. Can't cancel the 10 and the 5 because that's a root 10, it's not a 10. There's no square number in there. So that will be the final answer. Square root 10 over 5. Get correct answer only. Okay. So you get 1. Basically, if you multiply by square root 10 over square root 10, 1 mark. Final answer, 1 mark. Question 16. Bang, 3 brackets. This is not too difficult. You just need to take it slow. Just do the first 2 brackets by itself first. There is another way of doing this, but I'm telling you, people make mistakes. First 2 brackets. Okay. X times x, x squared. X times minus 3, minus 3x. 4 times x, 4x. 4 times 3, 12, and a plus and a minus is a minus. Again, if you're going to make a mistake, this needs to be red. It's going to be there. Okay, that's where everybody makes their mistakes. Plus and a minus is a minus. And then the 3x plus 2 is still hanging around, waiting for its time to come. Okay, before we handle the 3x plus 2, it's going to have to hang around for one more round. I'm just going to simplify this bracket. The x squared stays an x squared. Minus 3 plus 4, or 4 minus 3 is 1x, or just x. You can put a 1 in there if you don't want to get confused. And then the minus 12 is also there. Okay, now the 3x plus 2, its time has come. Okay, I'm gonna use some colors here. Let's go with light blue. Alright, so we're gonna start with the x squared. I'm gonna multiply the x squared with the 3x, which is gonna give us 3x cubed. I'm gonna multiply the x squared with the 2, which is gonna give us 2x squared. So now I've done the x squared with both the 3x and the 2. Okay, next color. Now the 1x. 1x times x, 1 times 3 is 3, and x times x is x squared, and then 1x times 2, they're both positive, so 1 times 2 is 2, and the x hangs around. Okay, so I did the x with the 3x and the 2. Now the minus 12 times 2, so 12 times 3 is 36. It's a plus and a minus, so it's minus 36, and there's an x there, so it's minus 33x. And then 12 times 2 is 24, and a minus and a plus is a minus. Okay, by now, if you messed it up there, you'll probably mess it up here. But okay, yeah, okay. So now we just need to simplify. 3x squared, there's 3x cubed, there's no other cubes here, so that will be 3x cubed. Then the 2 plus 2x squared plus 3x squared, those two we can add together, so 2 plus 3 is 5, and remember when we add, the indices stays the same. Okay, then we got the plus 2x minus 36x, or rather like minus 36. Imagine it's minus 36 degrees outside. You must be in space. And it gets 2 degrees warmer. That would be minus 34x, and that minus 24 is just hanging around. And that, ladies and gentlemen, should be the correct answer. Okay, again, I don't know why that is there. Let's check. 3x cubed plus 5x squared minus 34x minus 24. Bam. Yes, that's correct. But okay, look now where you can score some marks. Okay, because often you can, okay. Okay. So basically, for this expansion here, you get 1 mark, and you're allowed 1 mistake. So if you did a plus there, you can still get that 1 mark. Okay. And then for expanding this one, now this is a tough one for example, there's 2 marks, all right, clear. But if you expanded this correct, and again, okay, so but if you have this, you got 1 mistake, you get this 1 mark, or you got all that correct. Okay, that's how the marks is awarded. Moving on to question 17, some wonderful probability. Bag contains 6 red, 3 green, and 1 blue marble, right? So that will be a total of 11 marbles. 2 marbles was picked random from the back with replacement. That's some bold. It means they take them out, they put them back. Find the probability that both marbles are green. Okay. What the hell? Who said it's 11 marbles? It's 10 marbles. Somebody can't add up. Alright. So, 3 green marbles out of 10. There's a chance of 30% of picking a green marble when you take it out. But then you put it back and you take out another one. So, 3 over 10 again. Okay, and then we just need to remember the AND or the OR rule. The and the OR rule, or the and or the OR rule. Anyway, there's 2 rules with probability. There's the AND rule, and there's the OR rule. AND rule, you multiply. OR rule, you add. So, find the probability of picking both green marbles. Are we picking a green one, or a green one, or are we picking a green one and a green one? Yes, and, right? So we need to multiply this together. Multiplying fractions, top with top, 3 times 3 is 9, bottom with bottom, 10 times 10 is 100, and there it is. 9 out of 100, or 9%, or 0.09. Don't ask anybody how do I write it. See, it says or equivalent, so you can write it as a decimal fraction or a percentage. Okay, but anyway, 1 mark for your working out there. 3/10 times 3/10, and then 9 out of 100, or 9%, or 0.09. Okay. Okay, next one. Another bag contains 4 red counters, 2 yellow counters. So that is 6 counters. The 2 counters are picked at random from the mix without replacement. Means they take them out, they chuck them away. Okay, it's gone. Complete the diagram. So yes, as you can see, the probability of putting a red one is 4 out of 6 because there's 4 red ones. Getting a yellow one is 2 out of 6. Okay, and then if you go the second time, you've picked 1 red one. There were 4, now there's only 3. There were 6 counters, 1 is gone, so there's only 5 left. Okay, so if you do pick a red one first time round, all the yellow ones will still be in the bag. So that should still be 2, but 1 is gone, one of the red ones, so there will be 5 left. So the probability of picking a yellow one is 2 out of 5. But if you pick a red one first, which was 2 out of 6, okay, there will only be 1 red one left out of the 5 because one of those yellow ones are red. That's gone. Okay, but if you pick a yellow one and then a red one, there should still have been 5, and there still will be 4 red ones in the back. Can you see that 4/5 plus 1/5 gives you 5/5? It always has to add up to 1 because all the possibilities need to be counted. Just like over here, okay, 3/5 times 2/5 is 5/5. It has to add up. Okay, and that's it. Okay, that is 2/5, 4/5, 1/5. That will give you how's the marks awarded. Alright, basically they're saying here they give you 1 mark for 2/5 and then 1 mark for 4/5 and 1/5. Okay, find the probability that one of the 2 counters is yellow. Okay, 1, only 1. So what are the possible routes we can take here? Okay, one of them is yellow, which means you pick a yellow one and then a red one. So this is the probability of getting a yellow and then a red. Okay, and that will be 2/6 and 4/5. Okay, what do we do add here? Is it multiply or add? Well, you have to pick a yellow one and a red one. Yeah? Not a yellow one or a red one. A yellow one and a red one for 1 to be yellow. So the and is multiplying. So picking a yellow one and then a red one will be 8 out of 30. Okay, but there's another possibility. You can pick a red one first and then a yellow one. Then one of them would be yellow. So this is the probability of picking a red and then a yellow. Okay, picking a red one first is 4 out of 6. And then, so we multiply, a yellow one is 2 out of 5. And that's another 8 out of 30. So there are 2 possibilities. You pick a red and a yellow one, or you pick a yellow and a red one. You see what I said there? Or. So it's getting this one or that one. So then we're going to have to add them together. 8 over 30 plus 8 over 30. Remember, denominators stay the same, and that's 16 out of 30. Okay, do I simplify it? Don't know, just do it. Do I simplify it? What would that be? 8 over 15. Sure, right, 8 over 15. But the mark scheme says no. Oh, mark scheme says 16 over 30 or equivalent. So yeah, my 8 over 15 will be correct. But you could have left it 16 over 30. Doesn't matter. Okay. you get basically you get a mark for this. Hey, red, a mark for this and a mark for that. If your tree diagram is wrong but you do the correct calculation, you get a follow-through mark. And then 16/30 or 8/15 or 32/60. Okay, don't try to change this to decimals or percentages because it's going to be a waste of time and just unnecessary. Okay, so that's probability done. Moving on to question 18. One day, Anya runs 12 kilometers. That's good, Anya. 12 kilometers is good. At a speed of X kilometers per hour. The next day she walks 10 kilometers. That's just to get, to get the acid to build up in the muscles, get it out, the stiffness, get rid of the stiffness. She walks 10 kilometers at a speed of X minus 4 kilometers per hour. So obviously she's a bit slower because she's walking. Write down an expression in terms of X for the time she spends running. Let's start with speed, distance, time. There is the formula. Speed is distance, kilometers divided by hours, time. If you ever forget it, it's in the units. Kilometers per hour is distance divided by time. Kilometers per hour. And we want to know the time. So, if we want to know the time, we need to do distance divided by speed. Okay. So, the time will be the distance divided by the speed. Okay. Which is, what was the distance? 12 divided by the speed, which is X. Okay, now remember, expression doesn't have an equal sign, so you can just write 12 over X. There is one mark, 12 over X, nothing else. Write an expression in terms of X for the time she spends walking. Oh, that's the same thing. Okay, the time will be the distance, which is 10, divided by the speed, which in this times is X minus 4. So there's 10 and X minus 4. Okay, there it is. Straightforward. So one mark each. Question 18C. The time Anya spends walking. What's the time Anya spends walking? This is this time. Let's call this time walking. Is 10 over X minus 4. Is 1 hour more than the time she spends running. Okay. So, there's the time Anya spends running, and there's the time Anya spends walking. Now, the time she spends walking is 1 hour more. So, you get the urge to add the 1 there, but this is wrong. Okay. Because you're going to see, time walking is already longer. You add 1 hour to that, there's going to be 2 hours more. Okay. So, you need to add the time she spends walking to the time she creates. Time she's just running, which is quicker. If you add 1 hour to that, you get the time she's walking. Make sense? Because if you add it to the time walking, it's going to be even longer walking. But to get it equal, you need to add it to the one that's less. Right, so that's it. The time she spends running plus 1 gives us the time she spent walking. Now we got the time she spent running was 12 over X. Okay, was 12 over X plus the 1 hour, and that gives us the time she spent walking, which was 10 over X minus 4. Okay, now we need to get some from here to here. Okay, so we're going to have to move some stuff around. Okay, that plus 1 complicates things a little bit, right? It complicates. So we cannot, if we multiply the X minus 4, we have to multiply it with everything here, which we can do, But we cannot just multiply the x there because the 1 is not being divided by x. Because the 1x annoys me, I'm just going to leave it there on the left hand side. And I'm going to leave the 10x minus 4 on the right hand side. And I'm going to take all of this, and move it to the other side. Remember, this is a positive 12 over x, so it's going to become a negative 12 over x. Okay, this makes it a little bit easier because we've done this before, simplifying an algebraic fraction like that. We've done that in question 14D. Remember, we did the smiley face, multiply the two bottom ones together, bottom right, top left, top left. So we do the same here. Okay, the 1 can hang around there. Multiply this together, which will give us x over x minus 4. Multiply the x with the 10, which is just 10x. Then there's a minus, and then multiply the 12 by all of x minus 4. Okay. Right, now I want to get rid of these fractions, and I can do that because now I can multiply this on the other side. And 1 times anything stays the same. So that will be x minus 4 equals 10x minus 12x minus 4. Now things looks a little bit easier. Okay, so we do x times x is x squared, x times minus 4 is minus 4x. Expanding the brackets, 10x needs to hang around a little bit longer. Minus 12 times x is minus 12x. And 12 times 4 is 48. Good, man. Look, there's a 48. And the minus and a minus makes a plus. Let's simplify that a little bit more. X squared minus 4x equals 10x minus 12x will give us minus 2x. Okay, so you can see everything is on the left hand side of the equal. So let's just do that. Let's leave the x squared and the minus 4x on the left. Move the minus 2x, it becomes plus 2x. Move the minus up, the plus 48 becomes minus 48, and then there will be nothing left on the right because I've moved everything to the left. We put it 0. So we're left with x squared minus 4x plus 2x is minus 2x minus 48 equals 0, and that's what we're looking for. Okay, it's very important that these show questions, right? Show, that you show every step, because that counts marks. Okay, so you get 1 mark for this, but I guess for that as well, or equivalent. So I mean this and this is the same. So if you got that one, I'm sure you get a mark. Okay, and then for the rearranging, so they've done it as a different way, it seems. Okay, so then for rearranging, so I guess you'll get 1 mark for this, 1 mark for expanding the brackets, and only if you have these 3 marks do you get a mark for this. If you just write this down, 0 marks. You need to have these 3 marks to get the A1 mark. Okay, depending on M3. So you don't get this mark if you don't have the previous 3 marks. Okay, so the show questions show a lot. The more you show, the better chances you have. Use factorization to solve the equation. Okay, you can solve this using the, well, you don't have a calculator, so you can't use the calculator. The other way is factorization. Factorization, put 2 brackets with an x and an x, because x times x gives us x squared. Now, if we multiply the last 2 terms together, we need to get minus 48. So let's think of things we multiply together to get, well, let's start with 48. So we can do 2 times 24, that will give us 48. 3 times 16, yeah, that's 48. 4 times 12, that will be 48. What else is there? 6 times 8. And I think that's it. Now, when we add the middle two terms together, we need to get minus 2. So which one of these can get us to anything near 2? That would be the 6 and the 8 when we add them together. Well, when we add them now, we're going to get 14. But what if this is a negative 8? That will give us negative 2. Brilliant. And if we make this a negative 8, that will give us negative 48. Brilliant. And that's it. That's our two terms. A positive 6 and a negative 8. This requires some practice. Okay, but let's just check, yeah? X times x is x squared. X times minus 8 is minus 8x. 6 times x is 6x. Together, this would be minus 2x, yes. And then 6 times 8 is 48. A plus and a minus is a minus. So that's all good. Right, so we have factorized. Now we need to solve. Factorize done, solve. Okay, so x plus 6 equals to 0. X minus 8 equals to 0. So x is minus 6, x is 8. Bam, done. Mark scheme. Alright, so there's other methods of doing this, of course. It's a long story short. If you swap the signs around, you get 1 mark. So if you had minus 6 plus 8, for example, you can get one mark. Right. Okay, so partial factorization. Or if you add this together, you get minus 2. So you're going to have like minus 10 and 8. Add them together, you minus 2. You get a mark there. Okay, and then solving. Then correct factorization, 2 marks. And then minus 6 and 8 is just 1 mark. Okay, so factorization is quite important. So what is the time Anya spends running? So, since we haven't invented the time machine yet, the time cannot be negative. No? So x must be 8. So the time she spent running was 12 over 8. Remember, time running was 12 over x. Time spent running was 12 over x. We just said x cannot spend minus 2 hours running, so it must be 12 over 8. So 12 eighths of an hour. What is that? Let's simplify. That would be 6 over 4. So half it again. 3 over 2. 3 over 8 is 1.5 hours. 1.5 hours running 12 kilometers. Not bad, Anya, not bad. Fractions, decimals, doesn't matter. They don't say anything about leaving it as an improper fraction, but I'm sure that will be wrong. And it's a follow through, so it's 12 divided by whichever positive answer you have here. Okay, I'm sure if you leave it as an improper fraction, they'll give you a mark. It doesn't say you have to simplify it. Just do it anyway to be safe. Right, question 19. Find the value of 27 over minus 2/3. Wow, what a. Remember the rules of indices. Let's just get rid of that minus first. So remember this rule that if you got, let's say, a over minus b, you can write it as a denominator. So we can write that as 1 over 27 over 2/3. Now we got rid of the minus. Okay. Remember the next one, which is fractional indices. So you got a over 1 over b. That can be written as a root. So we can write 27 is a 3. Whatever's on that is the root 3. Remember now, this is all over 1. Then what happens to the 2? Well, just square it. So it's 1 over root 3 27. What is root 27? What times what times what is 27? Can you remember? What's the cube, right? So cube numbers. Think about the cube numbers. 1 cubed is 1. 2 cubed. 2 times 2 times 2. 8. 3 cubed is, you got it, 3 times 3 is 9, is 27. So that means the cube root of 27 is 3. So that will be 1 over 3. But that 2 has been hanging around since the start. Squared. 3 squared, of course, is 9. Answer 1/9. Know your rules of indices. Okay. You can do it in a different order. Look at that. They've done 27 squared. You can do the square first and then cube root, but that's going to be a long way to do this. Okay, so look at that. They only give you 1 mark if you write 9 to the power of minus 1. So make sure not to write it as negative indices in the end. I guess any one of these steps will count a mark. And then 1 over 9. Right, question 20. So with a bit of practice, of course, it's not too difficult to remember the values, trig ratios of the angles. Okay, so draw yourself a little table. Let's give ourselves some more space here. All right, let's give, we need to do sin, cos, and tan. Okay, and then we need to remember the angles. It starts with 0 degrees. And then we got 30 degrees. This you're going to have to memorize, but they're not too difficult. You must have seen them many times. Be right around 45, 60, and the last one, 90. Right, let's go for this. Right, remember this. Now we start with sin, and we start with 0, and we write down the numbers 0, 1, 2, 3, 4. And then we square root them. Square root, square root. And the last thing to do is divide them all by 2. And that is it for all of sin. That will give you the answers. Okay, but we can simplify them a bit. Okay, first of all, the square root of 0 is 0, and anything divided by 0 is 0. So that will just be 0. Okay, here the square root of 1 is, we can just, square root of 1 is 1. And we leave that as a 2. We can leave this one like this. Yeah, the next one as well. But you might see in your calculator textbook sometimes slightly different. And all they've done is they did square root of 2. And they multiply it by square root of 2 over 2. Which then will give you square root of 2 over square root is 2 over 2 square root 2, which is 1 over square root 2. Okay, so they might see that value, but perfectly fine to use this one. And the same happened with square root 3 over 2. Okay, you multiply that by square root 3 over square root 3, and it will give you 3 over 2 square root 3, although not many people do that. So you can leave them the way they are. Just the last one, the square root of 2, of course, is 2, and 2 divided by 2, square root of 4 is 2, 2 divided by 2 is 1. Great, so we've got that done. And the good news is the cos ratios is just the opposite. So sin 0 is 0, so we put the 0 there. Then we got a half. Sin 45 stays the same. Then square root 3 over 2, we put that over here, and then 1 over there. Okay, tan is similar, slightly different. We do 0, 1, 2, 3, 4. We need to square root all of it. So that's the same. But then when we divide it, we just do it in reverse. We divide it by square root 4. divide this by square root 3, divide this by square root 2, divide this by square root 1, and divide this by square root 0. Okay, and then just simplify. Okay, so any square root 0 is 0, anything divided by 0 is 0, so we can change that to 0. Square root 1, of course, is 1. We leave that the same. Anything divided by itself is 1. Square root 1 is 1. Anything divided by 1, so that would just be square root 3. Right, and then the square root of 0 is 0, but anything divided by 0, that's mathematically impossible. And if you remember the ton graph, we got that asymptote. So this is not possible, impossible. It's not infinite, but so there's no value here. Okay, you can just say there's nothing, doesn't exist. Asymptote, square root of the ton 90 asymptote doesn't exist. Some people infinite sign goes on, yeah, whatever. Okay, math error on your calculator. Right, so yeah, you can remember how to do that. This question will be easy as pie, because we just check. Okay, all right, let's start now. We see we got a 90-degree angle, yeah, which means we can use Pythagoras, but if there's an angle involved, we use SOHCAHTOA. So let's label the sides of the triangle here. This over here will be the hypotenuse. This is opposite the angle, and this is the adjacent. Okay, now we're not using the hypotenuse because we don't have it. They don't want to know it. So the O and the A, we need to use the ton ratio. So it's going to be 2R. Okay, 2R means we do ton, then the angle, which is 30, equals the opposite is first, so that goes at the top, and the adjacent at the bottom. Okay, so we're doing well. Raking in the marks. Okay, so then we want to know what x is, so we're going to multiply the x over there, which gives us x ton 30 equals 6. Remember, we're multiplying it. So we want the x alone, so we're going to divide the ton 30. So basically, we're just swapping around the ton. So now we got x equals this. But do we know what's tan 30? Well, you did your homework, you studied. Tan 30 is 1 over root 3. So that means, let's just make some space here. If it doesn't crash. Right. So x will be 6 divided by 1 over root 3. We can put this one over 1, can't we not? So dividing with a fractions, we leave the first one the same, 6, yeah. We can invert this, square root 3 over 1, and multiply. So that will give us 6 over square root 3, 1 times 1, and that's the final answer, 6 square root. That's the exact value what they were asking about. There it is, 6 root 3 or equivalent. Don't know what can be over 1 maybe. Okay, so there are different ways of doing this. You can use the sin rule, like they've done there. Okay, but I think it's 1 mark for having the 1 root 3 somewhere. Doesn't matter when you do it. And 1 mark for writing down the ratio correct. It's not very clear how they award all the marks, and then I guess simplifying it correctly. Yeah, not sure how they more the marks here. Oh yeah, definitely this is a mark. Rearranging it, that's a mark. Okay, learn your table, no SOHCAHTOA, and you can do this. Question 21, vectors. Read all the informations. Very careful. Okay, OABC is a rhombus. This has value. It's not there for no reason. What is a rhombus? A rhombus is a square made crooked, which means not only is these opposite sides parallel, they also have the same length. Yeah, so that is parallel and they have the same length. That is an important feature with vectors, where everything that is parallel and the same length is exactly the same vector. O is the origin. We'll see if that's important later, but remember they said that. The diagonals of the rhombus intersect at P. Now that's another thing about a rhombus. Diagonals intersect at a 90-degree angle. I don't know if that's important. I just think, how can this one sentence be important? Another thing about the features of a rhombus, the diagonals, they cut each other in half, which means P is exactly halfway between OB and AC. See how much we can take from that rhombus. Then it says this, OP is 2M, AP is N, you can see that. Okay, so got a lot of information there. Now let's start the party. Let's use this nice. Find the terms of M and M in its simplest form, OA, which means we're going from O to A. They want to know this one here. Okay, but with all vectors, we take the path that we know. Okay, the path that we know is this one, going from O to P, because that gives us 2M. So that's going to be 2M. And then we go this way, which is N, but we're going, see there we went with 2M, we're going in the opposite direction, so that's minus. Okay, and that will be a bit 2M minus N. Not too difficult, this is why this counts. 1 mark, 2M minus N. Okay. Right. Now, let's clear the clutter. Right, and we just write in there what we know so far. So we know now that this is 2M minus N, which means this is 2M minus N, because they are parallel and they are the same length. They have the same vector. So OC is the next one to find. OC, let's see, OC is this one here. Again, let's take the path we know. So this will be 2M. Choose the blue. So we go along here again, OP, that will be 2M. We're going in the same direction. So that will be 2M. And then we're going to go here. Okay, remember what I said about the diagonals of a rhombus? They are the same length because they're cut in half. So this and that is the same. So you could say this is also N because it's got the same direction as N and it's the same length. So all we need to do is add N. So that's 2M plus N. Okay, you can see there. Right, so that's another 1 mark. We're raking in the marks now. Okay, just remember what this also means. We clear out the clutter. Okay, so this is 2M plus N, which means this will be 2M plus N. Remember, okay, this is goes the same direction. This will be N. That's the same direction. That will be 2M. We've all got every line there now as a vector. So what do they throw at us next? D is the point. Oh, let me bring another point. Such that AD equals 10M minus 3. AD. Oh my shot. Oh my word. AD. So, show that it's a trapezium. And that's the only thing I can think of here. Is if you extend that way. you make a point D. See? Because then put another line here, and now we got a trapezium. That's what they were going for. OADC and AD in this direction, going from A to D, is 10m minus 3n. 10m minus 3n. Yeah. Okay, let's just not confuse this. This was 2m minus n. Okay. Right, but after staring at this trapezium for a significant number of time, let's see what this trapezium will be labeled. This trapezium will be labeled ODBC, right? ODBC. Or if you go the other way around, OCBD. Doesn't matter. Those are the four corners of the trapezium. But you go down here and you say, well, what is going on here? There is no B and there is an A. So how can we make this a trapezium that looks different? Which we have to put D in a different spot. And the only spot I can think about is maybe, well, we can't gonna put it that way. If we go this way, it can be OD. BC. AD. So we extend AD. But there is no B there either. So B cannot be a corner. O, A, D, and C needs to be the corner. So we're going to have to extend this like over here. And extend that. See, now we got a trapezium, a wonky one. That's like this. And in this trapezium, the four corners is O, A, D, and C. Like they want. O, A, D, and C. Okay, with AD being 10m minus 3. Okay. So there we go. Let's make it a little bit prettier. Okay. So we need to have this is a straight line, because it needs to be parallel to this over here. Looks a little bit better, but it's still ugly. Okay. All right, which means we want these, this and this to be parallel. Yes? Okay. Now the proof is parallel. We need to show, you see, parallel lines are the same. If it's longer, it's going to have the same vector, but just maybe double the length. So maybe CD will be twice 2m minus n, because that will be 4m minus. That's just a guess, for example. So if CD is 4m minus 2n, or maybe 3 times as long, which will be 6m minus 3n, or maybe 4 times as long, which is 8m minus. Those will all indicate parallel lines with OA, which is the same as CB. Okay, so what this means is, oh, this scarfuffling, it means we want to find this vector. We want to find CD. I want to find out what is CD, vector CD. Right, so what is vector CD? Well, it's 2m minus n plus that. We don't know what that is, so let's take a different path. Let's take this path going up here. So that's an n and an n, but in the opposite direction, so that will be minus 2n. And then we go along here in this direction. Remember, AD is 10m minus 3. So that's plus 10m minus 3n. Okay. So simplify that. The 10m stays 10m. And minus 2n minus 3n is minus 5n. Now if we factorize out of 5 there, that will give us 5 2m minus n. Okay. So what does that say? This whole length here is 5 2m minus n. So it means this part here will be 4 2m minus n. And to get 5n. Okay. And OA is 2m minus n. Thus they are parallel. So that means thus OA is parallel to CD. Also means CD equals 5 OAs. Now if you've got two sides that is parallel, that means OADC is a trapezium. A lot for 3 marks. I know, these people are crazy. Let's have a look. 2 marks for having 2m minus CD. Yes, so yeah, there's a lot of moving around. Okay, so you get, well, basically 2 marks for this, or any part of it. Then showing that is 5 times. You have to show it's 5 times. Yes. Okay, all of this is 1 mark, but the core is you show that is 5. That is 5. Yeah. Quite a tough question. I have to say. Examiner's report say very few students got full marks here. Question 22. Right, differentiation. Remember, differentiation is the gradient of a tangent to a curve. To differentiate, we need to do this n times whatever in front to get the value in front, and then subtract 1. Okay, so if this is a 2, then n must be 1 more. N must be 3. That means the equation of this line is y equals, well, something x 3. 3 times what gives us that? So that is 3. That must be 1. 3 times 1, so when we differentiate, I'm doing this now full, we're doing backwards. 3 times 1 is 3. Subtract 1 there, that's 2. That's why n is 3. Okay. Right, so then the next one, there is a minus 12 and there is a 2. So 2 times what gives us minus 12? Must be minus 6. Two times, no, because 2 times minus 6 is minus 12. Subtract 1, remember there's a 1. So yeah, that's right. So Q must be minus 6. And then you get 1. 1 times 9 is 9. Subtract the 1 will give you x to the power of 0, which is 1. It's the same. Okay. I don't know any other way to explain this. This is just the answer. 3 and minus 6. Okay, you have to kind of think of in the reverse, or trial and error. Yeah, so 3 times 1 is 3. 3 minus 1, okay. 2 times minus 6 is minus 12. 2 minus 1 is 1, which they left out the 1 because you don't need it. And then you get plus 9x. Put a 1 there, that will give you plus 9x to the power of 0, which will just be 1. That's why that's fallen away. Practice your differentiation. the coordinates of the turning points of the curve. Okay, so remember now, if you have a curve, there's the x and the y axis. Okay, this would be, because this is a cubic graph, we'll have something like this, and we'll have two turning points there and there. Now, the tangent to these will be a line like this, two horizontal lines. Horizontal lines have a gradient of 0, so that means that will be dy over dx is 0. The gradient of those turning points is 0. Okay, now, but this is also the gradient. There it is, they've given it to us. Okay, so that needs to be equal to 0, so we can then say 3x squared minus 12x plus 9 equals 0. So we need to find two turning points from here. Okay, point, of course, has got an x and a y value. First thing we can do is we can divide everything by 3. So that will give us x squared minus 4x plus 3 equals 0. So remember, we need two points, so we're going to factorize this. Multiply, well, we're going to put the x in the x. Numbers to multiply together to get 3. Well, that's only 1 times 3, isn't it? So this is going to be a 1 and a 3. But when we add them together, we have minus 4. How do we get minus 4? Well, it have to be minus 3. Minus 1 and minus 3. Well, that will give us minus 4. Because minus 1 times minus 3, that gives us a positive 3. So that means they are both negative. Just double check this, yeah? X times x, x squared. Minus 1 times minus 3 plus 3. And then minus 1 minus 3 minus 4. Yeah, we got this correct. Okay, so we split that up. So x minus 1 equals 0 and x minus 3 equals 0. That means x equals 1 and x equals 3. Great. The turning points now we got, the x values is 1 and 3. We just need the y values. And where is a y? Where do we find the y in all of this? Well, there, the only y I can see is that. That's the y we want, okay? Remember that I already figured this out, that the equation actually is y equals x cubed. So the y equals x cubed minus 6x squared plus 9x. That's the equation. There's the y. Now we just need to put these values in there. Okay, first I'm going to put the 1 in there. So y equals 1 cubed minus 6, 1 squared plus 9 times 1. Good. 1 times 1 times 1 is 1. 1 times 1 is 1. 1 times 6 is minus 6. 9 times 1 is 9. So that would be 9 minus 6 is 3 plus 1 is 4. So that must be 4. Okay, we have to do that again. Let's do this one. Dark purple. So we're going to do all of that again. I'm going to just do it here. So we got y equals, this time we got x is 3. 3 cubed minus 6. 3 squared plus 9 times 3. Okay, we've had this before. 3 cubed is 3 times 3 is 9 times 3 is 27. 3 squared, of course, is 3 times 3 is 9. 9 times 3 is again 27. 27 plus 27, that was going to give us 54. 6 times 9 is also 54. So y is 0. So that's the turning point. So my graph is not quite this. This one turning point is there. Oh, yeah, so 3, 0. Oh, that's just up a bit. It's all positive. So rather the graph would look something like this. Just draw it over here. Okay, we did it in blue before. So the turning point is 1, 4. I correct, it's going to be like this. 1, 4, 3, 0. Yep. Okay, that will be 1, 4, and this will be 3, 0. Those are where the graph turns. All makes perfect sense. 1, 4, 3, 0. I got mine in a different form. Look, they've used the quadratic formula to do this. I did factorization. Okay. Okay, so there's a lot of marks you can pick up here even if you don't have much of a clue. I mean, first of all, if you set this equal to 0, bam, that's 1 mark. Factorization, 1 mark. There you can use the quadratic formula without a calculator. And then you get 1 mark each for each correct. 4 marks. Keep going. Question 23. Thought never this day would come. The last question on the paper. Simplify. Stare at it for a while. Meditate. Look at the clock. See how much time you got left. And then you jump right in. Okay. Let's factorize. Okay. 2x squared is 2 times x times x. 10 can be broken down in 2 times 5, and there's an x. So let's get the common factors from here. There's a 2, it's the common factor of 2, right? And an x. And an x. We can take an x. So factorizing that will have us 2x in front. Bracket, there's an x. There's a plus. And there's a 5. Top factorized. Probably get 1 mark already. Okay, x squared minus 25. Remember this is a complete square. Okay. It's got an x squared, so we know we're going to make 2 brackets. An x and an x. Remember this, and these questions is always, one of the brackets are the same, always, so there must be an x plus 5. But how do we get minus 25? Well, we have to have a minus 25, because if we expand, x minus 5, x plus 5, expanded, x times x, x squared, sweet. X times 5 is 5x. Minus 5 times x minus 5x. 5x minus 5x is nothing. That's why there is nothing there. And then minus 5 times 5 is minus 25. Sweet. Got it. Okay. So that means we can cancel these brackets and we're left with 2x over x minus 5. And that's, you feel, it's a good way to finish this paper. Okay. Let's quickly look at the marks. 1 mark for factorizing that one correctly, 1 mark for factorizing that one correctly, and 1 mark for the final answer. Good luck. You will get there. Keep fighting the good fight, and you're gonna get that A or A star.